Good morning everyone. I thought I would do another introductory video, this time into annuities. So we'll do some basics. There'll be more videos on annuities I'd expect as we get more into the detail, but you know, I just wanted to, once again, these first videos are focused on kickstarting your revision, making sure you're not wasting time on the basics. So right, okay, so annuities. What are they? So present value of a series of cash flows. So you can think of them as an MPV when we think about what we've done to individual cash flows earlier on in the course. So an example. So let's do time 0, 1, 2, 3. Let's do a cash flow of 2, 2, 2, and 2 at each of them times. Let's find the present value of each cash flow. So 2, 2v, 2v squared, 2v cubed. Note this is a regular amount. The annuity is then the sum of these present values here. So these four here. And in this case is 2, 1 plus v squared plus v cubed. If you remember our notation, there's 4 payments in here. So 2 here. The P is 1, which we'll talk about in a little while. And this starts in advance, so we'll put the double dot on. And all we need to make sure that I is, the units of I is per annum effective. If it was arrear, it would be v plus v squared plus v cubed plus v to the 4. Obviously that would be a different series of cash flows, that one. So this is just to show, all this one's for is to show the difference between the arrear and the advance. Yeah. We've got some formulas for each of these, so let's go over here just to see if this is still on camera. Yep. I'll get rid of that. 1 minus v to the 4 over d, where d equals I over 1 plus I. We know all that. And then here 1 minus v to the n, or 4 I should say, tut, and that's over I. This time. Good. So I always say, be careful. So if we have an annuity here of n, we have an amount here of c, then we have an interest which has to be per n. So as I always say, make sure that all the units are all the same. So if you're working it in this unit here, so say this is n years, n units, which is years here, make sure that you've got that, then you've got your annual payment there, and then your interest rate needs to be annual as well. Always make sure them 3 elements are consistent with each other. We also have these annuities where the frequency is different from 1. So rather than payment of one payment per period, it can be more or it can be less. So we usually use P there, don't we, for that, if you remember. So we can have C, and then we put the P in there. Our quick formula then changes to that, in this case. But be careful that the I, which is used in the V, is 1 plus I to the minus N. This here. So be careful that we use I here and I P3 there, the nominal rate. If we wrote this out as a series, so this is in arrear, so rather than being at time 1, it's at time, the first payment, so we've got C, first payment is at V, 1 over P, I think, yeah. Yeah, so say P. So whenever I do these, I always think of the example. I just do P half the. So payments are half yearly. So P equals 2. So that means if that was in arrear, the first one would be in 6 months' time. So that'd be 1/2 of a year. Correct. Dot 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 dot. Plus, and then the final payment is still a V to the N. I think we can write that as a summation as well. So now the summation is every payment. So you have to be a little bit careful here. We have to then say every payment is that. Should have done it there as well. So apologies for that. And then I think this is then, so K, if we just use K as the variable there, so we say the first one is, this is in arrear, so the first one is 1 to NP, because this is every payment. So if you think if it was 10 years and it was twice a year, there'd be 20 payments, so that would be that. So your discount factor, your power for your discount factor becomes, so it becomes your count variable, the K, over P, I think. So what happens at NP? NP over P gives V to the N, so good, yeah, that's right, so good. Right. Now we can also, when we've got these annuities which pay more or less frequently than the N time unit. We've done that in terms of N there, but equally we can do it in time periods of P3. So once again, we'll think about the half yearly. So C over P would be each payment. Here, how many time periods of P? So we now went into NP, so that's how many time periods we're in now. P now goes to 1 there, and all we need to make sure is that the effective rate of interest is IP, i.e. per P, per half year, if we use P equals 2, something like that. So I think I've told most of you, and one or two of you have picked this up very well. I always try to go into this world because I find it's easier when you start calculating all this type of thing, rather than having to use, otherwise you have to use the IP, and I get fed up with calculating all that. So that's why I try to go into the time period which is equal to the frequency, effectively. However, both methods are fine, and as long as you use your memory and your calculator to obviously put I in, and then to put IP in, you know, you can then put D in, and you put DP. You know, you then got the suite to allow your calculations to be pretty slick in the exam. So that way, so using the you know the end period is fine as well. I haven't got on to continuous annuities just yet. We can do, but I'll do that in the next one. I think the only other thing I was going to add in now is, remember that I said that an annuity is an NPV. Remember, with NPVs we can start to move them forwards or backwards in time if we have effective rate of interest to do that. So an example here is we can form an SN which is equal to AN, so we've got that. That's what and I didn't really explain that well. We can multiply that by 1 plus I to the n. So you can see all we've done was we've taken this and then we've accumulated that. So rather than being at the start of the period, it's now the value at the end for a series. Okay, right, I'll do some more of these, but that will do for now, I think.